Morning everyone. So for this week we will have module 5 and 6, but for I will be having a lecture about module 5 first. But before that we have to first again review some terms, okay? So we have here the term population and sample. Okay. This is very important in statistics that you know your population and your sample. So what do we mean by population? When we talk about population, let's say for example, this is a community and these are the people in the community, right? So we got the people in the community. So that is the population. So the entire community is the population. All of the people here are the population. Now, if I get 3 people, these people, so we have 1, 2, 3. Okay. So we got 4 people. So we got 4 people. This 4 people is representing the population, which is called the sample. So simply, when we talk about sample is part of the population. Okay, so example, in your classroom, you are 50 in your classroom, and then I got 5 people who are going to solve on the board. So those 5 people are part of the population and they are called sample. Okay, so we're done with that. So now we go now to our sampling distribution of the sample means. Okay, first let us discuss every we call this property. Number 1, a sampling distribution of the sample means is a frequency distribution using the means computed from all possible random samples of a specific size taken up from a population. So meaning, so let's say for example, later we'll have an example on that. Okay. Huwag na ito pala. Okay, so first, let's have the steps in constructing the sampling distribution of the means. So number 1 is you should know how to identify the possible number of samples. Okay, I mean the number of possible samples that can be drawn from the population using the formula and combination of small letter n, where capital N is actually the size of the population and the small n is equal to the size of the sample. For our statistics classes, for the capital N, it's always that it is representing the population. For the small n, it is representing the size of the sample. Now, second step is list all possible samples and compute the mean of each sample. Third step, construct a frequency distribution of the sample means obtained in step 2. Now have an example. So we have here a population consists of 5 values, which are 2, 3, 4, 5, and 6. This is your population, and you are to draw 2 samples from the population. So what are the possible outcomes? For you to be able to know how many possible outcomes can you make, you can use your calculator. So you can use, we have here the formula, the population combination of the sample size. So if you are going to look at your calculators, you can see their symbols like, okay, let's input. What is your population? Your population is 1, 2, 3, 4, 5. So 5 values. So we have 5 values. So 5 combination, where's the combination? Okay, here. Combination of how many samples? Again, what will be the sample size? N is equal to 2. So 2. So the answer is 10. So meaning 5 combination of 2 is equal to 10. So we have to list the 10 possible outcomes. So therefore, there is 10 possible outcomes. Okay, so that is your step 1. Step 2, list all possible samples and compute the mean of each sample. So we have here, list all the possible outcomes. What could it be? We could have 2, 3, 2, 4, 2, 5, 2, 6. What else? We have 3, 4. Another is 3, 5. We have 3, 6. Next, 4, 5, 4, 6, 5, 6. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these are the 10 possible outcomes. So after getting the sample, this is the sample. Let's solve for the sample mean. Sample mean. Okay, so 2 plus 3 is 5 divided by 2. That will be 2.5. 2 plus 4, that will be 8 divided by 2, 4. 2 plus 5, 7. So that will be 3.5. 2 plus 6, 8, 4. 3 plus 4, 7, 3.5. Again, sample mean here. Mu. Okay, sample mean. 3 plus 5, 8, 4. 3 plus 6 is 9, 4.5. 9, 4.5, 10, 5, and 11, 5.5. So this is now your possible outcomes and their sample means. Okay, now, so these are the sample means. Do not forget the sample means because we need that for the next step. So third step, let's go to the third step. For our third step, we are going to construct the frequency distribution. Okay, take note of the word frequency. You are just going to count how many times that they have a sample mean of like this. So what are the possible sample means? So let's have now the sampling distribution of the sample means. I'm sorry for my handwriting. So we have here sample mean, which is x bar, represented by x bar, the frequency, probability of x. So that will be your table. Okay, let's construct. Again, what are the possible sample means? We have 2.5, we have 3, 3.5, 4, 4.5, 5, and 5.5. Okay, now, how many times that you had a sample mean of 2.5? It's only 1. For 3, it's only 1 also. For 3.5, you have 2. For 4, we have 2. For 6, for 4.5, we have 2. And then we have 1, 1. So we have here total. Okay. Now, P of x. So P of x is the probability of x. So meaning, there is 1 over 10 possible outcomes that you might have 2.5 as your sample mean. Next, 1 over 10, 2 over 10. No need to do it in simplest form, the fraction. So 2 over 10, we have 2 over 10, and 1 over 10, and 1 over 10. So for the total, so that you could check also. So how many frequencies? 1 plus 1, 2 plus 4, plus 2, 4, plus 2, that will be 6, plus 2, 8, plus 1, that will be 10, which is correct, right? We have 10 possible outcomes. And for the probability of x, going back to what we have discussed before, it should be equal to 1. Is it equal to 1? 1 plus 1, that will be 2, plus 2, 4, plus 2, 6, plus 2, 8, plus 1, 9, plus 1, 10. So 10 over 10, which is equal to 1. So that is now your sampling distribution of the sample means. Right, so we're done with the sampling distribution of the sample means. Now, we go to the properties of the sampling distribution of the sample mean. If all possible samples of size n are drawn, a population of size n, which is capital N, with mean or mu and standard and variance sigma squared, then the sampling distribution of the sample means has the following properties. Number 1, the mean of the sampling distribution of the sample means is equal to the population mean. That is, okay, so we have, again, the mean of the sampling distribution of the sample means is equal to the population mean. That is the first property. Okay? Next, number 2. So the best that you could have an estimate is the sampling distribution of the sample means is equal to the population mean. Number 2, we have the variance of the sampling distribution of the sample means, sigma squared, is given by sigma squared of the sample means is equal to sigma squared all over n, small n, times capital N minus n all over n minus 1 for finite population. Finite population. Okay. So what do we mean by finite population? If you know the population, there are researches that you know your population, then you could use this formula. But if you do not know your population, so sigma squared is equal to sigma squared all over small n. That is for infinite or infinite population. So when we say infinite population, you do not know the exact number of the population. There are researches that you do not know your exact number of population. So let's say, for example, the total population of Baguio City. Sometimes you cannot get the exact number of the population here in Baguio City. So you could just use the infinite population variance formula. So next, number 3. Another property is the standard deviation of the sampling distribution of the sample means is given by sigma of sub x is equal to sigma all over the square root of small n times the square root of n minus n all over n minus 1 for finite population. Finite pop. So for finite population, where the square root of n minus n all over n minus 1 is the finite population correction factor. Okay? And next, we have, if you do not know your population, we have sigma sub x is equal to sigma all over the square root of n. So that is for infinite. Pag hindi mo alam yung population, total number of population, ito ang gagamitin. Okay, so those are the properties of sampling distribution of the sample mean. Now, we go to the very important theorem that we'll be using in statistics. Okay? So hard to erase. Okay, get ready? So we have what we call the central limit theorem. So what is the central limit theorem? Okay, let's just read first before I explain. The central limit theorem states that the distribution of sample means approximates a normal distribution. As the sample size gets larger, assuming that all samples are identical in size, regardless of population distribution shape. Okay. For the central limit theorem, for you to be able to understand it easily, when we say central limit theorem, the larger the sample size, the more that you are going to have a normal curve. Syempre, if common sense, let's say for example, you are going to have a research of your class. You are 50 in your class. So you are 50 in your class. So once that you are going to do the research, can you all interview this? Maybe no, maybe yes. But if you do not have time, you cannot interview them. So the first group have interviewed 16 people. The second group have interviewed 25 people. The third group have interviewed 46 people. Now, for the central limit theorem, which do you think has the most reliable data or output? Of course, the 46. Because the larger the population size, or I mean the sample size, the bigger probability that you get to the normal curve. So kung ito yung normal curve nyo, so yan. The higher your sample size, mas nag-approach kayo sa normal curve. So that is the central limit theorem. Okay? Now, let's have an example. Example already. A population has a mean of 60. Okay. So has a mean of 60. So let's write population has a mean of 60. Okay. And a standard deviation of 5. So standard deviation of 5. Okay. A random sample of 16 measurements are drawn from this population. So what is 16? 16 is now your sample size. Okay. Compute its mean and standard deviation. Okay, number 1 step. Identify the given information. So we have identified it. So this is actually step 1. Step 2. Find the mean of the sampling distribution. Use the property that, okay, we could use the property that, the first property, that the mu sub x, or the sampling distribution of the sample means, is equal to the population mean. So meaning our population mean is 60, which also means that our sample mean is 60. Right? So this will be our mean for now. Next, third step. We have find the standard deviation of the sampling distribution. Use the property that, okay, so for here, are we going to use a finite or infinite population? What is this? This is actually infinite population. You do not know the population, okay? So we use the formula sigma sub x is equal to sigma, or the standard deviation, all over the square root of n. So let's solve. So we have, what is our standard deviation? 5 all over our our sample size is the square root of 16. Answer is 5 over 4, or 1.25. This is now the standard deviation of the sampling distribution of the sample means. What is the mean? This is the mean. Did you get it? Okay.